So you know that Tableau can query databases, or it can query the data extracts or a data located in Excel file and convert that into some nice looking charts and data visualizations. So from the data source to the final rendering, there are various steps and the processes that the data goes through. And what you can do, how the data gets filtered is affected by which step of the pipeline the data is located at. So in this video, we're going to look at how the data flows from the source system. Maybe it's the database, again, SQL Server, Oracle, or maybe it's a Tableau data extract, and it can be an Excel file to all the way down to the chart. So if you are using Tableau extract, one of the first thing Tableau does is queries the data in a database, and then that gets copied into a proprietary file structure which is called as a hyper data extract format. If you're using extracts from further operations at the time of visualization creation are run against the extract, Tableau does not query the database. Again, everything that Tableau needs is now located within the extract file or this hyper file. If you're not using an extract, the query will be passed down to the database, and there is obviously no extract involved. So that's your first step. From that data source, which can be an extract or a conceptual definition of joins and tables as defined in data source, you can create filter on top of that. So that's going to be the first step where any kind of data filtering gets applied. So you can create extract filter. An extract filter basically means Tableau passes something in the where clause to the database, so data is not even retrieved from the database, and this helps to keep the size of your extracts smaller. This can be very helpful. For example, if your company maintains database of orders over the last 10 years, and you know that querying last 2 years of data is going to be sufficient, this can be a very handy tool to just query the last 2 years. And many databases have functions such as getDate, and you can automate that so that always every single time you refresh, the last 2 years of data is retrieved automatically. The second step after that is a data source filter. What this means is that if you are using data extract, after the data is queried from the extract, maybe it's located within the hyper file, Tableau will not include those regions further down in the processing. This can also apply with like query connections. The next step is what is called as a context. Again, any filter in Tableau you can add as a context filter. Any quick filter you can easily convert as a context filter. All you're doing with that is pushing down where the filtering happens in the processing pipeline. And this can be very useful, especially when using with level of details, and particularly fixed level of detail. And we're going to have a quick lab on this in a bit. The next kind of filters are sets, conditionals, and top end and fixed LOD. Sets can be very handful. Tableau actually creates some internal data structures for sets, and they can be really good in comparison. For example, let's say you want to compare the data for one region versus another, and you define 10 states on the eastern coast as your eastern region, and maybe 10 more states and on the west coast as your western region. You could write a formula where if state code is in XYZ and so on, and then create region definition as east and the other way. Or you could also define this as a set. more often than not, sets perform really well because of some pre optimizations that Tableau does on that. The next thing that comes in the processing pipeline is the dimension filter. Those filters are processed ahead of measures. Remember that. The next thing that comes is blending. So blending is basically Tableau's way of providing runtime joins between two different data sources. And blending happens at the individual view level. So when you create blends, you define the potential relationships, like the join criteria, but they are not turned on. You turn them on a view by view basis. What that means is, if you're using multiple views in a dashboards and there are multiple blend criteria that are defined, your dashboard performance may get slowed down. This highly depends on what's the level of linking, which is another way of saying join between two data sources. The more granular, more uniquely identifiable data that you're joining with, think of things like person ID or dog ID in our example, the slower the performance is likely to be. Especially imagine your data is bringing back millions of records, and then you have two such data sources that are blended together in a worksheet. Tableau has to do that join criteria on millions of records for each view. Far more preferable in this case is to see if you can join them at the data source creation itself. Tableau provides an incredible ability to join two different data sources. So that could be a very good option to improve the performance. Basically, the idea is the further down the pipeline you go, the more is the processing. So you'll benefit from reducing the amount of the data or the granularity of data. And we're going to look at one example here on performance as well with our box and whisker plot, where we try to bring in every single dog information with individual details, and you can see that the visualization performs very poorly. And as soon as you reduce, like here, maybe let's aggregate that information at the state level, city level, and maybe the amount of row count goes down by 60-70%, and that really helps with the performance. So just be aware that where you're joining can have a big impact on the performance. The next thing that comes is include exclude filter, include exclude level of detail expressions. Again, they can be very handy to basically find out, if you're trying to do average for a particular city versus what's the metric for a state, and you are showing that on a line by line basis, and each line contains the city. So in this case, you want to jump higher. You're jumping if you think about the geographic data at the country, state, and city level, maybe though you're showing data about individual city, there are some metrics you're trying to get from the state level or the country level, and those kind of things can be helpful to jump up and down the level of detail that you have on a particular visualization. Again, we're going to have an example on fixed LOD, which will make it much more clearer, so just hold on until then. And the final thing is table calculations. Again, table calculations can be extremely handy. Think of something like you are looking at like a cross tab of data in Tableau, and there are 50 records. With table calculations, you can look at the record number 1 or 2. There's a function called as lookup, and you can retrieve that value and use it in your calculations. So a running total, that's another example of a table calculations. And trend lines and reference lines are something that are calculated at the very last point in the pipeline. So just be aware that, where you're filtering, how much data is coming at each step, and that will help you optimize your dashboard performance as well.